Hey guys, welcome to homework 5.4. We are working on reflections of functions, reflecting on the x and y axis. Important to understand the keywords there. So go ahead and go to desmos.com and let's spend a little time learning how to use. I'm using my computer to screencast this instead of my iPad since I couldn't get the actual graphing to show up last time. So this is my first one here. Let's give it a go. All right, the first problem says there f of x equals 3x to the x power. Well, that's a exponential equation. And the second one is g of x equals negative 3x. So let's type that one out, see what it looks like. G of x. So some other function, we'll call it g, is negative, and then in parentheses 3 to the power of x. And notice how it reflects the red one, which is f. It reflects it across the horizontal axis, which is the x-axis. So it's reflecting it right here on the x-axis. This is a reflection across the x-axis. So how would you do number one? In terms, it says rewrite each function g of x in terms of the basic function x. So I'm going to say g of x is really the opposite of f of x. Okay, I think maybe this parentheses is not necessary. And there you go. You see, this is in terms of f. I'm saying that the g is really the f, the opposite of f. So opposite of that will be reflecting over the x-axis. So we don't write this down on your paper. This is a horizontal reflection, as I said earlier. So let's look at number two, and you want to be using your computer to type these out so you can really visualize these using the caret. This is number two. So number two says f of x is 3 to the x power, and that is another standard exponential. And g of x is g of x, well, it's really f of x, but we're actually going to change the inside of x. Notice how the x, only the x became opposite. Okay? Only the x became opposite. Last time the f was on the outside, be a negative, which would make it upside down. And look at this cool one. If you make them both the horizontal translation and the vertical translation, you'd have double translations here. But for this one, here's that one. And let me put the other one, what we had originally. So g of x equals 3 to the power, I'm going to put in parentheses, negative x. So you see my orange one, and it's the old one, and the purple one is underneath the orange one. It's underneath here. So what you really want to understand is if the x is opposite, if the x is positive here and then you flip it here, it will reflect on the vertical axis, on the y-axis. It's kind of backwards, right? So if the x changes to the opposite, it flips on the, we call it today the princess wave. It flips on the vertical axis, which is the y. It reflects on that. And if the negative is on the outside, for example, this one, put this one positive, it'll reflect on the horizontal axis, okay? So that would be the right one right there. All right, for number three, you want to do 3, 4, 5, and 6, and pay close attention to that. All right, so go ahead and do those and pause it here. Be very careful with 5 and 6 that you are putting the negative in the proper space. And what you should do is you should type them regular, and then make sure that when you're rewriting them as the f, that it does show up correctly. And what I mean by that is if you type the exact one, the same one as in the in your homework, okay? So that's the number 2 again. The new one, that when you're going to type, you have to say that it's in terms of x, f rather, 3 to the negative x. Let's see what happened here. G of x, oh, there we go. Notice how the black totally is on top of the orange one. See, look, this is making, see this orange, triangle is an error. So it doesn't like this. So I figured out my mistake is that I was trying to put the input as a function, an exponent. In actuality, all you need to do is put it regular, because this one already has it as the exponent. So you're saying whatever the x value is, you're going to make it opposite. Alright guys, so number 7, it's talking about coordinate notation. So here is the first one, and here is the second one. It's called g, I believe. So g of x equals the opposite of 2 to the x power. Okay? So notice here that the x's of each of these points are the same, but the y's are opposite. So what you want to do is, I need to get a program that I can write with. Since I'm not using my iPad, I can't use my finger to just type something. So let's open up a quick Word doc. How about Paint? Okay, so we're saying here, this is number 7. Okay. So we're number 7, we're saying the x's are the same, but the y's are opposite. Okay. Notice how these, all the y's are positive, and all of these x, all of the blue y's over here are negative. So each point on the blue line, the y's are opposite of the red line, but the x's are actually the same. So you want to graph both of these and study them and understand that. You also want to be able to do this without graphing. You can understand by looking at this one that the negative will make all of the y's opposite if the negative is on the outside. But if the negative was on the inside, for example here, for example this one, this is not on your homework, but here, what's opposite here are the x's are going to be opposite. The y's are the same, see how they're both going up, but the x values would be the same. I mean opposite, excuse me. The x's are opposite, but the y's are the same if the negative is here. There's a little bit of opposite thinking, you know. So, excuse me. Let's look at number 8, and then I'll let you do these by yourself. Okay, number 8 is 2dx. Oh, it's actually this one right here. Okay, weird. Okay, so number 8 would be the x's are opposite, but the y's are exactly the same. So what we're saying is that each of these points in here, for example, this point versus this point right here. Let me see if we can get this some nice ones. How about this one? See, the x is 1 and the y is 2. In this one, the x is negative 1 and the y is 2. So the x's are opposite. This one right here, you got negative x's, positive y's, and on the opposite side, you have positive x's and also positive y's. All right, so do the rest of those, and I'm going to go to 13 right now. The directions are each coordinate plane shows a graph of f of x. sketch the graph of g of x. All right, so let me delete this one. So f is okay, so these are kind of drawn, so you have to, they don't really give you the exact number. So you want to sketch the graph of this. Let's pretend this one was 4 to the x power. So we want to sketch g, and it says g is the opposite of f. So opposite of f would be, would be typing it into my graph g. So it does take a lot of time to type it, but I think if you can visually see this, you can start to get the idea. So if the negative is on the outside of the function, okay, I'm going to write this down somewhere. If the negative is on the outside of the whole function, it'll flip it on the x-axis, because all the y's become opposite. But if the negative is on the inside next to the x, it'll flip it side to side on the y-axis. All right, so go ahead and draw the rest of these and test them out on your computer and make sure. Don't just test them out and copy what you have. Try to deeply understand what's happening. Okay, pause it here, and I'll continue on 19. All right, 19 says, write a function g of x that describes each reflection of f of x. Okay. So the function for 19 is 3 of x, 3 to the x power, and we want to reflect it on the horizontal line. So we want to reflect it on this line, on the y, on y equals 0. So y equals 0 means the x-axis. It means every point on the x-axis, the y is 0. So we want to reflect 3 of x on that. So it should look like this. So remember, if you want to reflect it on the x-axis, you have to put the negative in front of the function, like that. So you want to reflect it on the y equals 0 on the x-axis, then you put the negative on the outside of the thing. You want to reflect it on the vertical axis, you put the negative in the front. All right, so 31 and 32, you just have to determine which kind of reflection that is, whether it's vertical or horizontal. And 37 and 38, you have to identify what kind of transformation is happening. So you can type them in and figure it out, visually see it. Okay, but spend a lot of time studying the different ways that you can reflect a function, whether it's horizontal or vertical. All right, guys, that's about it. I want you to post your understanding of reflections. And what I mean by that is, do not say, I understand this. What do you understand is the 5-point bonus question. What do you understand about the reflections? That's all. Bye-bye.